Hello everyone, it's Kateřina Peková again. Welcome here at our first iOS online talk in 2021. It's really nice to see such a great show up, and I hope that we will go through the talk without any major technical issues and you will all enjoy it. Firstly, I would like to establish just few rules so everything can run really smoothly. You have many options how to interact with the panelists or also another attendees, and we would like to encourage that your experience is as lifelike as possible. So firstly, you have an option to raise your hand. So that would be our priority, and anytime anyone will raise their hand virtually, we will call you up, unmute you, and you can ask the speaker directly. Also, there is an option to write down your question in Q&A section. We will get to these questions after the talk. And also you can chat with others, just so you know there's an option to chat with the panelists, but also with another attendees. So always make sure that you are writing to the right person or group of people. So that's basically it. Now I would like just to introduce our speaker, Mr. Jan Kaltoun, iOS platform lead, and along with him, another Jan Pacek, also iOS platform lead as STRV, whom I would like to give a word right now. So thank you very much and enjoy.
Thank you, Katka, for the introduction. It is my pleasure to introduce Jan Kaltoun, as mentioned, our platform lead, who's gonna talk about turning an iOS app into Mac app using the Catalyst technology. So soon you will discover how easy it is. And also, if you have any questions during the talk, you can post them directly to chat, and I will monitor that, and we can ask Honza at the end of the presentation to answer these questions. Honza, it's yours.
Hello. You can also use Q&A, by the way. That's the fancy chat. Let me share my screen. The correct one, hopefully. Mr. Pacek, can you see Keynote? I take
Looks
silence
good.
as yes. Excellent. All right. So let's get to it. Basically, well, today I want to tell you about the title that you see here. I would like to talk about something really quite exciting. It will be a story about how I ported an iOS application to macOS using Catalyst. And I learned a lot during this process, and it helped me to demystify a lot about what Catalyst is all about. And I'd like to share this experience with you today. Some time ago, I spent quite a bit of time researching Catalyst. Of course, there is no better way to try out a new technology than to code something real. And so I looked at the internal apps that we have here at STRV for a potential candidate. In the end, I chose our iOS department app. There's almost 40 iOS developers here at STRV, and it is frankly quite hard for everyone to remember what all your colleagues are working on. It is also quite hard for everyone to remember what our projects are all about, because there's a lot of them. And remembering who knows what and who to ask for is almost impossible, if you want to ask someone directly, of course. This app aims to solve all these problems. And it is also a nice playground and a great way to get the more junior developers when they join STRV up to speed. So let me first show you the app so that you know what we'll be working with in this talk. Firstly, there is a list of all iOS developers at STRV. You can open a detail of anyone and see their current projects and technologies that they feel strong in. Then there are projects and their details. You can see what the project is about, who is currently working on it, and who has worked on it in the past. You can also quickly get to the latest version of the app to check it out. By the way, those are, of course, not real projects, as some of those are quite confidential sometimes. I just mocked the project data for this presentation. That's why the weird names. Lastly, there's events and profile. At STRV, we have weekly iOS meetings, kind of like this one, where one of the engineers speaks about a topic they choose. And we have gathered a lot of material over the years, and this is the easiest way to watch the talks. In Profile, you can edit your info that is visible to others. As you can see, that this is a very simple app, which makes it an ideal playground for learning new tech. And additionally, we believe that having a desktop app will boost its usage a lot because we're coding on our Macs, after all, not on our iPhones or iPads. Although hopefully we will be coding on iPads soon as well. So the first time I opened the project and started porting the app to my Catalyst, I had some general idea about how this should work. First, you would find the magical checkbox and you would check it. You can find it in your target's general tab, and so far so good. Then, of course, I'd build the app, and something really quite beautiful would come out of it, like this beautiful Maps app in Big Sur. Just by pressing a magical checkbox and rebuilding the app, a Mac app would be born, and that would be great, right? Of course, this is a bit tongue-in-cheek, and no one can expect this to be so simple, but still, the general idea is something along those lines, right? So armed with the power of my imagination and unrealistic ideas, I started the actual process of porting the app. If you're not yet familiar with macCatalyst, it is important to realize that your macCatalyst app is basically your iPad app that is running on a Mac. Of course, you can and should, ideally, make adjustments specific to macOS, but in general, if your application is a good iPad citizen, your macCatalyst porting efforts will be much, much easier. So the first thing I did is that I ran the app on an iPad just to see how it looks. So it's not my code base after all, so I had no idea where it was. The situation turned out to be less than ideal, let's say. iPad was not supported at all, and so I began to understand what amount of work lay ahead of me. Nevertheless, I remained positive, and I went and checked the iPad checkbox that is located conveniently just above the Mac one. And voila, the app was running at least in a proper resolution. This is less than ideal, of course, but I still found it quite okay. At this point, it was really quite clear, though, that a lot of work was needed. Since your Mac app, though, is basically an iPad app in disguise, by making this iOS app be a good macOS citizen, I would be making it a good iPad citizen as well. So double the profit. It's just taking it from the other side. So when I went and checked the mysterious Mac checkbox, and suddenly Mac appeared as a run destination. By the way, the Mac checkbox only becomes available if you have the iPad one checked, thus indicating that your app supports iPads. And that makes a lot of sense given what I mentioned a minute ago. Excited about starting to update the UI of the app to look swell on a Mac, I pressed the play button. And not too long after the build failed, obviously. The app uses Firebase and other dependencies, and something was wrong. First, I got a really quite interesting error that one of my dependencies that was installed via CocoaPods required a development team specified. I did specify it, and it fixed it. So when I went and pressed play again. And soon after, I got a different error. Building for macCatalyst, but linking in an object file built for iOS simulator for architecture x86-64. Unfortunately, an error like this cannot be solved so easily. You may encounter an error like this in your apps too, by the way. It is quite cryptic, but it means that the dependency simply cannot be built for x86-64 architecture. I searched and found the issue to have been reported by others as well. Not too many, but some. And unfortunately, it turns out that the Google-cited library simply does not support Catalyst right now. Fortunately, in iOS 12, Apple introduced the Authentication Services framework. And after some digging into Google OAuth, I was able, quite easily, frankly, to implement my own authentication. If you've never used authentication services, please give it a try. It's more than sign in with Apple. After pressing play again, I got the same error for another dependency, and this time it was for Firebase Analytics. After a quick search, unfortunately, Firebase Analytics turned out also to not be supported by Catalyst just yet, or to not support Catalyst just yet. This may be a deal breaker for many applications because it's frankly quite important part of the app. So hopefully the support will be added sooner than later. For me, though, it wasn't. I can live without analytics for this project, so I made the code unavailable for the Mac target environment and pressed play again. This time everything went quite all right, and there were no more errors. This is really quite impressive if you think about it. All the errors were in third-party dependencies. The actual code of the app that we wrote built and ran just fine. And with 0 modifications, I built an app for macOS. And that's how you do it. That's how you build macOS apps. I'm just kidding. This is a pretty horrible Mac app, but it's something. Some apps may be even OK without any modifications, depending on the UI, of course. I can imagine maybe a game being just fine. I imagine, though, that most of the apps that are UI heavy will need a good amount of updates, especially if they haven't been built with proper iPad support in mind, like this one. So what can we achieve with macCatalyst? What can we do to make a pretty horrendous app on a Mac a reasonably good macOS citizen? A little disclaimer first, before we dive deep into it. I have never built a Mac app in my life before. I've always been an iOS developer only. The next slides show what worked for me in this particular scenario and what I hope will work for you too. But all the information that I'm going to be giving you may be pretty obvious to a seasoned AppKit developer who develops macOS apps basically nonstop. Coming from iOS world, though, this was all quite new to me, and I expect that for many, it will be the same. And that is actually the reason why I decided to prepare this talk in the first place. Having never built a Mac app before, I was properly impressed by even having the app build and run in the first place. Like, I haven't done almost anything, nothing specifically to my code, and it ran on a Mac, which is crazy, if you ask me. It turned out fairly quickly, though, that turning this ugly duckling into something pretty nice is actually not that easy, not that hard. Is this the best Mac app that you've ever seen? Obviously not. Is this better than a website? Very much yes. When you think about the cost versus benefit, it's a no-brainer, at least in my opinion. It is quite easy to get this app to this state, and for little money, you get a lot. Going from the app on the left to the app on the right took just a couple of days. This is the biggest takeaway for me. Using macCatalyst and building macOS apps is much less time demanding than I have originally anticipated. And honestly, as I mentioned, it's pretty easy too, with the latest incarnation of macCatalyst at least. As I mentioned, there is a substantial amount of modifications that needs to be done to get the app to a reasonably good shape on macOS. And here's the list of things that I chose to implement. I chose to modify structured navigation, add multi-window support, menus, contextual menus, toolbars with tooltips, keyboard shortcuts, some file management sprinkle in, touch bar support, and a lot of UI tweaks. Some of these are applicable to all apps and are sometimes even mandated by the human interface guidelines. Some of them are not. You may choose to opt out of some or add some depending on your app. It's up to you. So let's take a look at each of these points one by one and see what can be done. First, there's the overall structure of your app and how your users navigate in it. Looking at the app without modifications, something is obviously very wrong. But what is it? Well, it's the tab bar, at least in my opinion. The Apple Human Interface Guidelines specifically mention that tab bars shouldn't be used for Mac apps. And it makes a lot of sense. They feel very out of place on a Mac. They're very unexpected. You don't see an app with a tab bar. On a Mac, we're used to different navigation paradigms. So let's take a look at the app once again. There's a lot of weirdness going on as far as Mac app is concerned, but the tab bar is obviously the biggest offender. It feels alien. For the app not to feel out of place on a Mac, you simply need to get rid of the tab bar, and you have two options to do that. First is the segmented control, like on this example from Big Sur. A segmented control can basically serve as a tab bar. You simply put your tabs as the segments, right? Suddenly, the UI would feel good at home on a Mac because this is something that we're used to. Segmented controls are a good option and require the lowest amount of refactoring, at least in my opinion. But many apps tend to choose the second option. In iOS 14, Apple released massive improvements to split view controllers, and it seems that this is the go-to option for many Catalyst apps right now. With 2 or 3 columns and the translucent sidebar style of the primary column to the left, the split view controller really looks pretty great. It looks gorgeous, at least on Big Sur. If you can afford to only support the latest versions of the operating systems, and in this case, this means Big Sur, this is a very good option. For my app, the split view controller is perfect, as I need exactly 3 layers of depth in my navigation. I tried the segmented control style as well, and it was all right. It was fine, but the 3 columns felt especially right, given the future expansions of the app that I have in mind. By default, you get navigation bars in each of the columns, by the way, so I opted to hide them and instead implement a toolbar at the top, covering the supplementary and secondary columns. Showing a secondary view controller pushes it on the navigation stack anyway, though. So there I implemented a custom back button. You can see it all the way to the right at the top of the view controller. Similarly to the music app in Big Sur that has a similar kind of navigation paradigm as well. Implementing the new style of split view controller is actually very easy. First, to instantiate the split view controller with some style. This is the new API. In my case, it was triple column. You could choose double column as well. You set the primary background style to sidebar so that it's beautiful and translucent. And you set the preferred display mode and preferred split behaviors to values that indicate how you want your split view controller to behave. I'm not going to go in depth into that, but basically the behavior will be slightly different. And then you set the view controllers for the columns. Here I'm setting one for primary and supplementary columns, the one all the way to the left and the middle one, so that the UI split view controller starts with some content. And I'm also setting the compact kind of style of display here with the top bar controller. By doing this, you let the system handle transitions for you when, for example, on an iPad, you're transitioning from a full screen view to a slide overview, right? In a full screen view, you will see the split view controller. And when you transition to the slide over, you will see just the iPhone UI, which is pretty handy, and the system does it for you. So this is pretty great. The API is really good. If you want to show view controller in the tab or column all the way to the right, you simply call show detail view controller and it will be shown. It's very easy. The API is gorgeous. I love it. There's Windows on macOS, pun intended, which is something that we don't really have on iOS devices, right? There are scenes, of course, and on iPads, your app can run either in full mode, split screen mode, or in the slide over, as I mentioned. If your app already supports the iPad display modes, you're almost there with Windows. Windows are really so central to the macOS user interface that they deserve some special love when you're porting your app. After all, you could not really imagine using the system without them, right? There's one big difference compared to the iPad, and that is that the windows are freely resizable. Your users can simply drag the corner of the app to make it the preferred size. And this can lead to really quite weird shapes of your application, like this one on the screenshot, where the user shrink the views quite a bit while making them the usual height. Your app needs to be able to handle these scenarios, and some tweaking may be required in order to get a consistently good UI. Even if your iPad behaves quite well in all the display modes, there's still probably some work to be done. On macOS, you should also embrace multiple windows, right? On iPads, your app can run in 2 instances, and that is, multiple instances, and that is quite similar on macOS too. Feel free to use different windows for different purposes, though, as opposed to iOS, especially as a replacement for a model presentation that you do on iOS normally. For instance, my application starts with a login window that spawns a browser window for Google sign-in. Once the user logs in, the login window closes and spawns a new one with the actual app. You could easily do this transition within one window, of course, but here this feels Macy. You should support multiple windows, even just for the convenience of having multiple instances of the app running in parallel. The convenience of having the app open multiple times in different contexts is worth it, at least in my opinion. You could even spawn new windows to open just parts of the app. For instance, you may allow your users to open just a person or project detail in a new window separately. As a bonus, you get this tabbed view completely for free. The only thing your users must do is to click View, Show Top Bar in the menu bar, and they get this for free. You don't have to do anything. It's pretty great. To support multiple windows, you do basically the same thing as on iOS, and that is implement the scene handling. If your iOS app already supports scenes, it also supports windows on macOS out of the box. The menu and interaction situation on macOS is quite a bit more powerful than on iOS. Your users will expect to be able to navigate using the menu bar or associated keyboard shortcuts. They will also be expecting micro interactions on a right click on many of your views. If you're familiar with the menu bar, it's just a if you're not familiar with the menu bar, it's just a big menu thingy at the top of your screen, but I assume that pretty much everyone knows what that is. Menu bar and keyboard shortcuts are a must, in my opinion. Obviously, there is no menu bar on iOS devices, so there you have to start from scratch. You may have already implemented keyboard shortcuts, though, because on iPads, we now have keyboards. The menu bar is an ideal place to let your users navigate through your application with convenient shortcuts, right? In fact, each of the menu items can have a keyboard shortcut associated to it. For instance, in my app, I use the standard Command F shortcut to let the user start searching by focusing the search field. I also implement a quick navigation between the app sections using Command and a number between 1 and 4. Your apps start off with a menu already created. You can add items to it or remove them. And to modify your apps menu, you basically need to do just a couple of things. First, you override the build menu function in your app delegate, like this. Then in some class, or even in the app delegate itself, if you want, you implement the actual changes. You need to use the UI menu builder instance provided to you by the app delegate, though. Typically, you create one or more UI key commands instances to create your menu bar items with their associated shortcuts, like Command F in this example. You then either add them to an existing menu or create your own. The menus can be composed together. So in this example, I'm adding an inline group with one command to the edit menu that already exists, right? Use the property list parameter to differentiate commands with the same action and pass parameters to them. Like for instance, if I have the command plus number between 1 and 4. Last thing that you need to do is to implement the actual action that you specified in your key command. Don't forget to allow your view to become a first responder, though. Otherwise, your commands won't get through. Nothing will happen, basically. This is because the commands are handled by the system using the typical responder chain approach. Contextual menus are another feature that your Mac users will be expecting. I myself right-click around literally everything, even if just to see what hidden advanced functionality there may be in macOS apps. Contextual menus have been available on iOS since iOS 13, I think, already, and there's a good chance that your app may already support them if you have implemented them already. If yes, they will translate nicely to macOS automatically. If not, please consider implementing them. Both iOS and macOS users will definitely thank you for that. I chose the simplest example here on the screenshot. Oftentimes, I need to get a photo of one of my teammates to, say, put it on a presentation slide. And using this contextual menu, I can easily save the photo onto the file system. Very easy. Implementing the contextual menus is very simple. First, you create an instance of UI context menu interaction and provide it with some delegate. Then you add the interaction to the view of your choice. Remember, though, that the view needs to have user interaction enabled for this to work. Otherwise, you will spend a good amount of time debugging why the hell this is not working, as I did. In the delegate, the only function you need to implement is the one on the screenshot. Context menu interaction configuration for menu at location, which is a convenient tongue twister. In my case, this is very simple, though, as there is just one interaction here, simpler than pronouncing it. So I can simply return an instance of the UI context menu in configuration with the action handling the photo saving. Drag and drop is another feature that has already been available in iOS for a while, since iOS 11, I believe. Again, this is something that your users will expect, and you should implement drag and drop wherever it makes sense. In the simplest example, we can, for instance, let the user drag the person's photo into Finder directly to save it. And I do that all the time as well. Implementing drag and drop is very, very similar to implementing the contextual menu actions. Again, you simply create an instance of UI drag interaction and add it to the view. Then it's delegate, you implement the drag interaction items for beginning session function, which is another tongue twister, to provide an array of the items to be associated to this drag interaction, and then it just automatically starts working. That's really quite easy. If you haven't implemented those, please consider it. It's a bliss. The API is lovely. While Toolbars exist on iOS as well, macOS brings them to a whole other level. Mac users expect a toolbar to be at the top of your applications to interact with it or with them. Toolbar items may or may not be contextual to the currently displayed content, as for instance, here in the Finder. Maybe the macOS toolbar concept is unfamiliar to you if you're coming just from iOS. So here you can see what it looks like in Finder. It is positioned at the top of the window, and it provides navigation and actions, maybe contextual or not. So firstly, you should move your controls to a toolbar, basically when you're porting your application. This is one of the things that is specifically mentioned in the Apple Human Interface Guidelines. On iOS, you typically put contextual actions and their associated controls somewhere within your view, or maybe in the navigation item, right? But oftentimes in the view itself. On macOS, it is a very good idea to move those into the toolbar because the users will be expecting them in there. For instance, here on the screenshot, there are 3 buttons in the toolbar in the top right corner of the app. These are contextual to the displayed project and allow you to perform various actions like opening the app in the App Store. The iOS version of the app has 3 buttons in line in the project view, so it's very different. To the left of the toolbar, you can also see the standard icon for collapsing the sidebar, by the way. So this is something that your app should have if you have a sidebar. Also notice the sign out button in a toolbar, a different style of toolbar, in the bottom left corner. This item stays the same throughout the app's lifecycle, so it makes sense to put it there. In the iOS version of the app, this button would be available in the Profile tab because on iPhones, there's never going to be a sidebar like this. macOS users love to hover over buttons, especially if, like in the screenshot on the previous slide, there is no text next to them. To let the users discover what the buttons do, you should really implement the tooltips. Implementing a tooltip is very easy though, so you don't really need to do almost anything, and the benefit is huge. I know that this icon does not particularly scream test flight, and I think I should talk to the designers to design an icon for me, but the tooltip fixes the problem for now, so YOLO. Implementing a toolbar is not particularly complicated either. First, you need to create your toolbar and set a delegate that will handle the triggered actions. In this case, I'm creating it in the view controller the toolbar is associated with, and then provided through the chain of coordinators to where it needs to get to be applied. In my case, that is the scene delegate, but we'll get to that in a second. Then you need to extend the NS toolbar item with an identifier of your custom items. In my case, for member profile, there's just one. In the NS toolbar delegate, you should implement 3 functions. Toolbar default item identifiers to specify what items are available. Toolbar allowed item identifiers to specify what items should actually be displayed. And last but not least, the toolbar item for item identifier function that creates the actual actions with their the actual items with their actions. Like this one on the screenshot that creates 2 items. A default one for hiding and showing the sidebar, the one that you saw to the left, and a custom one for messaging the person that would be located to the right. Very simple. Yeah, the API is a little legacy, but still very simple. To connect everything together in the scene delegate, I react to the toolbar donation from the coordinator, and I set it as a toolbar on the title bar of the current window scene. Just 1 line of code, basically. And that's it. That's how you get your toolbar working. Some people love the touch bar, and some people hate it. Regardless, you should consider implementing it. Not only will you make some people really quite happy, it's not a lot of work anyways. In fact, if you have already implemented Toolbar, which you should, touch bar code will be very, very similar and familiar. For instance, here on the screenshot, I have the same 3 contextual actions that are available in the toolbar also present in the touch bar. As I mentioned on the previous slides, implementing a touch bar functionality should feel pretty familiar by now, because this concept is modeled around the toolbars. You could even say that the touch bar is a kind of a toolbar too, and you'd probably be right. First, you extend the NS touch bar item this time with your custom item identifier, and then you implement the make touch bar function to create the instance of NS touch bar associated with these NS responder subclass. Setting up the items is very similar to the toolbar. You just create the NS touchbar item instances and associate them with their actions. Almost exactly the same as with the toolbar. So please consider implementing touchbar support. It's really almost no extra work. On iOS, we're used to presenting views modally, and it's a core concept that we're so used to that it may be quite tempting to bring it over to macOS in full power. That may or may not be a good idea, though. Firstly, you should consider spawning a window instead of presenting a view model in a macOS app. In my case, presenting views model felt quite a bit out of place. For example, showing a photo detail of a person feels really great in a new window, but really quite bad as an overlay of the view underneath on macOS. In cases where a model presentation makes sense, remember that there's no touching in macOS. You may be expecting some interaction paradigm from iOS that simply does not exist on macOS. Take a look at this example, for instance. On iOS, we're expecting the user to simply drag down on the view to dismiss it. On macOS, that is simply not possible. Instead, we need to add a specific button to dismiss this form sheet that by default displays modally on Big Sur. Next topic is file management. That is quite specific on macOS in general. The abstractions provided by the system work well, though. So in the end, even though it's quite specific and different, you may not end up having to do much as compared to your existing code in iOS app. Firstly, there is a proper file system on macOS available to you. Cheers. Some apps may use that more than the others. It's up to you, up to your use case, of course. In my case, I only need to save a file to the file system where the save photo interaction is triggered. This is really quite simple to do with the standard UI document picker view controller that you're probably quite familiar with from iOS. Using it triggers the UI that you would expect from a macOS app, and I really didn't have to do anything. Pretty easy. Well done, Apple. Really well done. Next, there are integrations with other applications, and it seems to me, at least from what I needed, that Apple have done quite a good job there as well. For instance, to change a profile photo, I need the user to be able to choose a photo from somewhere. I opted to let the user choose the photo from their photo library, as they would do on iOS. The standard UI image picker controller that you're most likely familiar with already transitions quite nicely to macOS as well. You may or may not want to do this, of course. Instead, you may want to let the user choose a photo from the file system. But if you choose to go with the image picker, it just works out of the box and without really any work. When you compare the before and after screenshots, you see two very different apps. Part of it is the structure, of course, navigation and other features that I mentioned. This is what makes your app look Mackie in general. The most time I spent on, though, was tweaking the UI to look good, at least good in my opinion. And this can go from adjusting the spacing to completely working a whole screen specifically for macOS. An important thing to note is that porting an app to macOS is definitely a trade-off between the beauty and how much time you are willing to spend, basically. You could definitely rewrite the whole app to have a perfect UI tailored to macOS. You could even write it in AppKit if you want, or in SwiftUI. The question is, though, whether you're willing to invest in that, and I suspect that many won't. Firstly, some UI just does not really translate that well, or at least my designers told me so when I showed them the intermediary progress. In these cases, some larger updates may be needed for the UI. Take a look at this example. On iOS, there is this rounded overlay view with a spring-like interaction on the image that enlarges it when you pull down and dims it as you scroll up. This UI does not make sense at all on macOS. Even with the interactions removed, though, the UI looks a bit weird. It starts to be particularly problematic as you expand the width of the window as the image is pinned to the leading and trailing edges. It just stretches weirdly and it just doesn't work. Instead, I opted to implement a bit of a different UI where the photo becomes a square within the view. I also removed the overlay as it just felt weird. I'm sure the designers would have a lot to say about this too, but I didn't want to bother them too much and they said, it's okay. I also noticed that it makes a lot of sense to move some controls from within the views. This unfortunately goes with a bit more refactoring, but in the end, you will probably end up with a much better app. For instance, here I noticed that pretty much every Big Sur app contains, that is Catalyst, right? Contains this search bar at the top of the sidebar. This is something that the users will most likely become accustomed to and will be expecting it from my app as well. In the iOS app, we have search implemented only in the members list. I decided to implement an app-wide search to enable the same UI as the other apps have. This was a lot of work, of course, but in the end, the app is much better. So you should consider whether some larger modification may be good for your app as well or not. But you don't have to do it. Of course, you don't. In case you need to implement tweaks like this, you need to have a way of differentiating what platform you are running on. And there are basically 3 ways of doing that. Firstly, there are the preprocessor macros. You can check whether your code is being built for the Mac or not. And this is required for the pieces of code that are not available on iOS, like the toolbar in this example that simply just does not exist on iOS. You can also check for the current UI idiom the app is running in. Beware, though, that unless you choose your app to be optimized for Mac, the reported idiom will be .pad instead of .mac. I'm going to talk about that in a moment. In the first example, I'm hiding the navigation bar if running under the .mac idiom, as I do not want the navigation bars to be displayed in the split view controller on a Mac. I do want them on an iPad, though, hence the Mac. In the second example, I need to add a cancel button into my form sheet, as the drag down interaction is not available on the Mac, as I showed you on the previous screenshot. And you can use the user interface idiom for that as well. It's a good use of it. Last but not least, when setting up your UI, you can introduce variations, not only based on the size classes, but also based on the current UI idiom. That is, if you enjoy using storyboards. Many people do, many people don't. It's up to you. The only piece of UI that was a bit complicated to update for me was the profile screen that I showed you on one of the previous slides. But even that took just a couple of lines of code using the techniques I just mentioned. On one of the previous slides, I mentioned the .mac idiom. .mac is a new idiom introduced this year that tells the system that you want your app to be optimized to run on macOS. When you check the Mac checkbox in the General tab of your target, you can choose between 2 options. First, scale interface to match iPad, and second, optimize the interface for Mac. I'm not going to go into too much detail about this, but bear in mind that if you decide to scale the interface to match iPad, your app will basically be that. The iPad app just scaled to 77%, by the way. It's exactly what it says it is. If you decide to optimize the interface for Mac, your app will run with additional modifications applied by the system. It will no longer be just a scaled iPad app. When you opt in to optimize the interface for Mac, a lot of things may break and some additional UI tweaks may be needed. They certainly were in my case. You will get benefits, though, of course. So let's see. If you're not using dynamic type, your app will look quite terrible after you opt in to optimize the interface for Mac. The scaling mode scales down everything, so the sizes of controls, text, images, etc., look similar to the other Mac apps, right? The 77%, because everything is a bit bigger on the touch devices. If you have fonts with fixed size, they will display at that fixed size when the UI is to be optimized for Mac. It will no longer be scaled. This means that the fonts and everything will likely be quite big, quite huge. My app was not using dynamic type, so I had to refactor it quite a bit. In the end, it looks better, though. It looks great, at least in my opinion. If you use the standard spacing when setting up your constraints, your content will get a bit of breathing space on a Mac. The standard spacing is a bit larger, and so some white space will be added, and it looks pretty great on macOS when compared to not using the standard spacing or scaling the UI. Your controls will look a lot more Mac-y as well when optimizing the UI for the Mac. This is particularly visible on the buttons, but also on other controls. Bear in mind, though, that if you have a large amount of customization applied to your controls, some may not transfer to the Mac at all. These 2 screenshots show all the aspects that I mentioned at the previous 3 slides. Notice the fonts that scale nicely based on the platform they're running on when I'm using dynamic type. They're a bit larger on iOS and a bit smaller on macOS, while using the same dynamic type version of the font. Also notice the spacing in the cells. On macOS, it becomes slightly larger and more white space is added. On iOS, the spacing is just a little smaller. Lastly, take a look at the segmented control, where the look and feel is a bit different compared to iOS. And color customizations simply did not translate over to the Mac at all. You don't have to optimize your interface for Mac. You don't. My app certainly did not need it too much. It would be just fine with the scaling mode. In the end, though, I was quite happy with the results. You should decide whether to scale or optimize based on the UI of your app and the amount of time you're willing to spend. And that is the common topic with my Catalyst. It works, even without any modification. It worked. It was a Mac app, and it's up to you to decide how much time you want to spend. And this is what I wanted to show you today. There's a lot more to talk about when it comes to my Catalyst, but we only have so much time. I hope that this talk showed you how powerful my Catalyst is, and I hope that you'll give it a shot. Please do. You can decide yourself how much time you want to spend on porting your app based on what I've seen and what you've seen in this talk as well, hopefully. But the important thing is that getting the basics up and running is really quite fast. The only problem that you may find that is oftentimes a deal breaker are the third-party dependencies, but even that situation is improving day by day. Finally, in my opinion, there's really no reason, except the dependencies, to not have a Mac app right now. And I really hope that we'll see more and more macOS apps come to life in the next days, weeks, months, and years. And with that, thank you so much. And we have space for questions, if there are any.
Thank you very much, Honza, for the awesome introduction to Mac Catalyst. Now, if you guys have any questions, please either raise your virtual hand, or use chat to place the question.
There's a question in the chat that says, for new projects, would you still recommend Catalyst or SwiftUI? That is a great question. So SwiftUI is bumpy even on iOS. On macOS, it becomes even bumpier. It's probably not the best idea to use SwiftUI for a macOS app right now. I know that some people tried, and many of them just gave up and are waiting for SwiftUI 3 because they just ran into performance or other issues that they couldn't solve. So for now, at least until September, at least, I would just go with Catalyst.
So there's another question. How did you structure your code? Is every class full of both iOS and macOS code, or is it possible to separate it somehow?
You use the same files. You use the same files for everything. That's the point of using Catalyst, that you're basically reusing the UI and you don't have to create anything new. Although you could like create separate screens just for macOS if there are some major changes needed. But to give you a little kind of insight into how many ifs you would have, the app has like 11,000 lines of code. There's I'm looking at it right now. There's 31 ifs for the idiom, and there is let's see, 50 results for the target environment. So for 11,000 lines of code, you have like, I don't know, 70 ifs. Most of them are in coordinators though, at least for the target environment, because you pass the toolbar, as I mentioned.
Okay, then we have a question in the Q&A section, and the question is about the new M1 processor and architecture. since it is possible to run the iOS apps natively on the new Macs, how do you differentiate when you use Mac Catalyst and when you install these native iOS apps? And the second part of the question is if you've already played or tried the new Mac architecture.
We did try it on the developer kit on the Mac Mini that we got from Apple. It looks like an iOS app running on macOS basically. I think that if you Google Peter Steinberg and Peter Steinberg and M1 or Apple Silicon on his Twitter, you can see screenshots of the apps running on Apple Silicon natively, and it just looks like the iOS or iPadOS app, exactly like it. With Mac Catalyst, you can have exactly the same scenario, but you get more power over customization of what you can do, right? You can customize a lot more easily and get to the desired result with Catalyst. But yeah, like having the apps run on M1 chips, especially for the games, that's massive. It's massive, massive, massive. It's great. And we kind of assume that this will improve the situation of the web app versus native app discussion, because if you really look at the Peter Steinberg's Twitter, you will see that, for instance, the Google Maps app that just doesn't have a native app without any modification is lots better than the web app. So we may see apps like that, even if the developers wouldn't port them in the first place. So I'm quite excited.
Thank you. And then there's a question in the chat if people can download the sample project.
I'm afraid not. Not this one, unfortunately, as it's internal to STRV. But if you guys would be interested, let us know. Maybe in the questionnaire that Katka will be posting after we finish up today, or by email, because we can create another meeting where I would show you how you actually do the porting. Like in the code, we would live code and port a simple app to Mac Catalyst.
Okay. Thank you for these answers, Honza.
Thank you for the questions.
I believe I don't see any more questions. Guys, if you have some, you can also raise your hand and ask Honza directly. I don't really see a tree of hands raised, so I guess that's it.
Great. Thank you so much for coming, and thank you for listening to me for past 45 minutes.
Thank you very much, guys, and thank you, Honza, for the awesome introduction to Mac Catalyst.
Okay, there are no other questions at the YouTube stream either, so I think that's it. So thank you very much to our attendees and also to Honza for a great event. So the next time we can see each other is on our next iOS event, which is happening in 2 weeks on January 28th. It will be 8 lightning talks from the people from our iOS department, covering different but really interesting topics. So please feel free to join us then. You can register at Eventbrite or check out the event section on our websites. And since you want to be proud of everything we are doing, and as Honza already said, we will be posting here the feedback form. So please feel free to let us know whether you enjoy it or not, or if you are interested in any, I don't know, topics we can cover in the future. So you should be able to see it once you close the Zoom window, but I will also post it here in the chat if you want to go there straight ahead. So that's it from me. Thank you guys and have a nice evening. Bye-bye.
Have a great evening, guys. Bye-bye.